Chapter 11, Understanding Randomness. To begin with, an event is random if we know what outcomes could happen, but not which particular values will happen. It is essential to remember that the most important aspect of randomness is that it must be fair. Now, to understand this concept a little better, please pick a number between 1 and 4. If you picked number 3, you are in good company because about 75% of the population also picks number 3. If you picked numbers 2 or 4, about 20% of the population picks these numbers, while only 5% of the population would pick number 1. You may be wondering why I had you do that exercise. The purpose of it was to show that humans are incapable of generating truly random numbers. Random numbers are lists of values that can only be generated by computers. However, even computer-produced lists are considered pseudo-random because they use a fixed sequence. So you may be wondering how we can get numbers that are truly random. Well, for the purpose of this video, we will refer to the random numbers table located on page A77 in the back of the textbook. Now that I have introduced the major skills and key vocabulary words, I will show you the superhero example to better explain what you just learned. In hopes of boosting their kids' meal sales, McDonald's has decided to include one Avengers superhero card in each kid's meal. McDonald's announces that approximately 20% of the cards are Hulk cards, 30% of the cards are Iron Man, while 50% are Captain America. For our problem, we will be calculating exactly how many kids' meals you will need to buy in order to receive all 3 cards. In order to answer this question, we will need to use a random model. Each model will represent a random Happy Meal. We just have to make sure that random numbers properly represent each percentage given to us. Like any simulation, ours will be imperfect, but it will help us understand the situation a lot better. Before we continue on with our problem, let's define some vocabulary words. To begin with, a simulation contains a sequence of random outcomes that model a situation. Additionally, a simulation component is the most basic event in a sequence. Furthermore, each component has a set of possible outcomes, one of which will occur at random. The sequence of events we want to investigate is called a trial, which usually involves several different components. The last vocabulary word is response variable. A response variable is what we record after the trials, or the end result. To begin the problem, our first step is identifying the component to be repeated. In our case, the component is purchasing Happy Meals. Step 2 asks us to explain how we will model the outcome. The digits 0 through 9 are equally likely to occur. Therefore, we will use digits 0 and 1 to represent the Hulk's 20%. We will use digits 2, 3, and 4 to represent Iron Man's 30%. And we will use digits 5, 6, 7, 8, and 9 to represent Captain America's 50%. This is one possible assignment of the digits, but there are other ways to do it as long as there are 2 digits for the Hulk, 3 digits for Iron Man, and 5 digits for Captain America. For step 3, explain how you will simulate the trial. A trial is the sequence of events that we are pretending will take place. In our problem, we are pretending to buy Happy Meals from McDonald's. We will continue doing so until we receive all 3 superhero cards. Next, we will clearly state the response variable. In order to do this, just ask yourself what you are looking for in the problem. We want to know how many Happy Meals we have to buy in order to get all 3 cards. So, that is the response variable. For step number 5, we are going to run several trials. Instead of actually buying the Happy Meals, we are going to pretend. First, we select a line of random numbers from page A77. Remember which digits represent each superhero card. For Hulk, 0 and 1 are shown in green. For Iron Man, 2, 3, and 4 are shown in blue, while Captain America's digits are 5, 6, 7, 8, and 9 in red. We need to keep going through the line of numbers until we have every single card. Once you have all 3 cards, write down how many Happy Meals you had to buy in order to get all 3. To organize the data, I used a chart to keep track of what happened. For step number 6, we analyzed the response variable. The entire point of this problem was to see how many Happy Meals we will need to buy in order to get all 3 superhero cards. In order to calculate this, you look at the column of numbers on the right. To find the average number of kids' meals, we add 6, 8, 4, 5, and 13 to get 36. We then divide 36 by 5 trials and end up with an average of 7.2 Happy Meals in all. The last step is to state your conclusion. Based on our simulation, we estimate that McDonald's customers who want all 3 superhero cards will need to buy at least 7.2 Happy Meals. Like I mentioned before, our simulation will always be imperfect. However, there are 3 things that you must watch for that can go wrong. First of all, don't overstate your case. In some sense, a simulation will always be wrong. After all, it's not the real thing. Never forget that future results will not match your simulated results exactly. Also, model the outcome chances accurately. A common mistake in constructing a simulation is to adopt a strategy that may appear to produce the right kind of results, but does not accurately model the situation. And lastly, remember to run enough trials. Although I only ran 5, if you were to do this problem or any other problem, you should actually run about 20 or more trials. After watching my introductory video for Chapter 11, you should be able to identify the following vocabulary words: random, random numbers, simulation, simulation component, outcome, trial, and response variable. Now for a mini quiz. Question 1A. When would you use a random outcome in a real-world situation? Question B. What situation did I use in my example? Question number 2. A. What is a random number? And B. Where could you find a list of random numbers? And last, question number 3. How many steps are there to making a simulation? This concludes my statistics introductory video for Chapter 11. I hope you enjoyed watching and have a much clearer understanding of randomness and simulations. Thank you.